This is a lab on IPv6 address configuration on the network itself. In this case, we're going to configure IPv6 address on the interface on R1 and R3, and at the same time, we're going to make use of SLAAC or stateless auto address configuration on PCA and PCC to automatically grab an IPv6 address from router R1 and R3 respectively. So now we're going to start off with router R1. Let's go into the config T mode. In this case, let's pull up the postman first. This is R1 for this case. So next, always remember for IPv6 to work on router, the first command that you must always do is the IPv6 unicast routing. Because if this command is not being executed on the router itself, all the IPv6 function will not be able to work. After this, let's go into the first interface, which is the gigabit interface G0/1. Okay. In this case, in the case of IPv4, the command actually is IPv4. But for IPv6, basically the IPv6 address configuration will be IPv6 followed by the address, followed by whatever address that has been given to you. And in this case, we're going to configure 201 db8 ACAD:A:/64. You can see that for IPv6 there are altogether 8 segments of address, but in this case I only have 4 segments because we are going to make use of the EUI64 parameter to let the router automatically grab the last 64-bit address by making use of the MAC address on the gigabit 0/1 interface itself. Press enter, do a no-shut. Next, we're going to configure the serial interface, which is S00/1. It is the same thing, IPv6 address FC00:1/64. So in this case, for this serial interface, we're actually configuring the full IPv6 address on the interface itself. Okay, do a no-shut. Okay. Next, we're going to go over to R3. Do the same thing with the IP address that has been given. Okay, IPv. Go inside interface G0/1, IPv6. Okay, 201 db8 ACAD:/64. Same thing again, make use of EUI64. Okay, no shut again. And go into interface S000. Okay, IPv6 again, C00:2/64. Okay. In the case of serial interface, always remember that you must do a configuration on the DC side of the serial interface, which is this router. Okay, always remember that you must have already executed the command IPv6 routing. Okay, as I mentioned that this is a prerequisite for all IPv6 process. Okay. Something to be aware of, if you take a note, there are many types of addresses that we can use in IPv6. We're going to get address, for example, the gigabit interface we are configuring starting with number 2001. So any number that starts with 2000 all the way 3FFFF, okay, this type of address is actually called a global aggregate address. Okay, any number that starts with FP80, okay, this type of address actually is called a link local address. And last but not least, the address starts with FC00. This type of address is also known as a unique local address. Okay. And another type of address that I'm going to highlight here is any address that starts with FF something. Okay. This is also known as the multicast address, which have a similar function in IPv4, which ranges from 224 to 239. So these are some of the the range of address that are more useful that you need to know in IPv6. So after configuring all the IP address, okay, you can actually do a show IPv6 interface brief to take a look at all the IP address that you have configured. Okay, and you can see that, okay, for R1 where we configure the gigabit Ethernet 0/1 and 0/0/1. Okay, something to significantly take note of is the FE80 IPv6 address, which is the link local address on the interface, which is automatically been assigned once you assign the IPv6 address on the interface itself. Okay, and you can see that for the 2001 address, the last 4 segments has automatically been assigned by the router itself using the EUI64 method by making use of the MAC address of the interface. Next, let's go to the PC, because we need to actually allow the PC to automatically grab the address, okay, from the router itself. Go to ipconfig. In this case, for SLAAC, you need to select to auto-config. You can see that automatically the IPv6 address and IPv6 gateway are assigned on the PC itself. Similarly, for PC C, we will do the same thing. Okay, so after you've done this, okay, you will be able to, okay, ping from PCA in this case to R1 and PCC to R3. Okay. In this version of Packet Tracer, take note that there is a bug whereby the gateway will be lost. So in order to have successful ping, always ensure that you have selected auto config and you can see the gateway address before you do your ping. Okay, something to take note of. Okay. So one question to ask you now is whether can PCA ping PCC? Okay, the answer is no, because PCA and C are in different network, and R1 and R3 doesn't know about each other connected network yet. So we're going to make use of static route in order to allow them to be able to ping to each other. And in this case for R1, I will need to reach the 2001 :BB8:ACAD:B network. Okay, so do an exit and do an IPv6 route, okay, which is the equivalent of IP route for IPv4, followed by whichever remote network that you need to reach. In this case is 201:BB8:ACAD:B:/64, okay, which is the network that belongs to PCC, and followed by either the local exit interface or the next hop address that allows R1 to reach PCC network. And in the lab, okay, you are supposed to make use of the directly connect local exit interface. Okay, in this case will be your 0/0/1. Okay, because that is the direction that R1 will need to reach PCC. Okay, you can verify by doing a do show run. You can scroll all the way down. Okay, you will be able to see that I already have a static route, okay, that is connected to PCC network on R1. Similarly, for R3, we're going to do the same thing. Okay, IPv6 route 201:BB8:ACAD:/64:0000. Okay, that's it. That is all that you need to do, okay, for the two router if you are making use of static route in order for PCA to reach PCC. Okay, so let's test out now. As I mentioned again, you need to ensure that you have make sure that your gateway is alive. If not, you won't be able to ping. So I'm now going to make a PCC to ping the IP address for PCA. Okay, say 201:BB8:ACAD:/FE19:B296. Okay, there is the address of PCA. Okay, let's wait a while. get a request timeout, it may be because of the gateway that has been lost. So go back and make sure that you have a gateway before you do your ping again. You can see that it's successful. So this is the bug that I mentioned, okay, in this version of Packet Tracer. So now I can PCA can successfully ping to PCC, and PCC can ping successfully to PCA, as I highlighted here. Okay. So other than doing a static route, the other type of route that I want to introduce here is default route for IPv6. Okay. So it's also quite similar, IPv6 route. Okay. So instead of 80 that we use for IPv4, okay, for IPv6 default route is much more easier because okay, the 80 can just be replaced by ::/0 to represent any address that I want to reach in the network. And in this case, I'm going to do make use of this default route to reach the network for PCC. Okay, similarly, I can do the same thing for R3. IP route ::0 /0 /0 okay, for R3. Okay, let's do a show run and verify the two routes that I've created. Okay, just take note that this is only for simulation. So either one of these, either you can make use of static route or you can make use of default route to actually reach, okay, the network itself. Okay, on the other side.